Imagine your immune system as an army, with T cells as the elite soldiers, leading the charge against invaders like cancer. But here's the twist. How strong these T cells are doesn't just depend on their training, but also on their energy supply. Let's zoom in on a game-changing discovery from a new study in Nature Communications. Scientists found that by deleting a single protein in T cells, called Ant2, they could actually supercharge these immune warriors. So, what is Ant2, and why does it matter? Ant2 is like a tiny conveyor belt inside your cells, ADP, between the mitochondria and the rest of the cell. This process is crucial for fueling all sorts of cellular jobs. You'd think that removing this conveyor belt would cripple the cell, right? But here's where it gets wild. When Ant2 is knocked out, T cells don't get weaker. Instead, they become hyperactivated, almost like flipping a switch to turbo mode. Let's break down the key findings. First, Ant2 deficient T cells respond more powerfully to threats. They multiply faster. They release more cytokines, chemical signals that coordinate an immune attack. Second, these cells change the way they make and use energy. They build up more mitochondria. They shift toward burning sugar for fuel. They ramp up proline biosynthesis. Basically, they act like T cells on high alert. But the real proof is in the results. In mouse experiments, T cells missing Ant2. Normal T cells treated with drugs that block Ant2. Both were way better at shrinking tumors. That's right. By tweaking metabolism, these T cells became much tougher cancer fighters. Why does this matter for cancer therapy? Many promising treatments, like CAR T cells, often fizzle out. The tumor environment is harsh, starving immune cells of nutrients and oxygen. This study suggests a new strategy. Preconditioning T cells by blocking Ant2 could make them more resilient, helping them survive and thrive in the toughest conditions. So, what's the big takeaway? By limiting mitochondrial ATP export, scientists can rewire T cell metabolism and unlock their full potential against cancer. It's early days, but this could open a new frontier in immunotherapy, making our immune soldiers stronger than ever. If you're fascinated by cellular metabolism, keep an eye on this space. The future of cancer treatment might start with a tiny tweak inside a single cell.